Hey everyone, welcome back. Uh, as you can see, I've got a change of scenery behind me here. One of my cats fell asleep in my office chair and I didn't have the heart to move her. So I'm in the living room or the dining room, I guess. I'll just record this here. So um, for this video, I'm going to walk through the weekly challenge lab on BugForge this week for Galaxy Dash. It's a prototype pollution vulnerability, which was something that I had not really done a whole lot with. So I had to, do some digging into it and learn a bit more about it. The Portswigger labs are really helpful for this. The Mozilla developer documentation is really helpful for this. And I'll link to both of those in the video description for this video, because in the time that I've got, and quite frankly, with my level of expertise around it, I wouldn't be doing it justice if I tried to do an entire video about prototype pollution. So um, I'm gonna do my best to give kind of an overview of what prototype pollution is, how it works, and some um, 30,000 foot high level recommendations for uh, mitigating the risk of prototype pollution. But I strongly encourage you to dig into this vulnerability a little bit more. There's a lot of really good videos on YouTube about it, and definitely would encourage you to take a look at some of those. So, um, kind of right off the bat, so prototype pollution is a vulnerability that allows an attacker to uh, add or modify properties of an object's prototype. So, in a lot of other languages that you may be familiar with, like Python or Java or C++ or whatever, um, where objects inherit from a class, JavaScript doesn't have that type of the same type of inheritance. JavaScript objects inherit via prototypal inheritance. So all objects in JavaScript have a reference to a prototype, which in turn has a prototype, and so on and so on and so on, all the way up to the object prototype, which is the end of the prototype chain. Okay, so um, the vulnerability arises when objects are merged together, and if that's done in an unsafe way, um, that is what could allow the attacker to be able to um, add additional properties to the global object prototype. Uh, and if that happens, then all objects that inherit from the object prototype will now have that extra property with the attacker controlled value. So I'm going to just go through here real quick, um, and just give you kind of an example before I get to the recommendations. So um, if I come over here, so I don't know exactly what the um, uh, code for the challenge looked like, because this is a server side prototype pollution vulnerability that we're working with in this lab, and not a client side prototype pollution. So I don't have full visibility on what the code looked like, but what I've done here is I've just created a user. I've created a constructor for a user object. So um, it has a couple of properties: view deliveries, manage users, manage org. So if I now say let user one equals new user, I can look at user one and I can see that it's an object and it has these properties. Oh, I forgot to. I created the user without passing in what it was supposed to be able to do. So sorry about that. Let me create a new one here. New let user two equals new user, and I want to say he can manage deliveries and he can manage users, but he cannot manage the organization. So now if I look at user two and I look at this object, we can see that it has those properties set. So now let me create a third user. Let user three, new user, true, true, and true. And we look at user three, and all of that is true. Well, if I look for an admin property, let's say the application is looking for an is admin property. Okay, user three is admin is undefined. Okay, so user three doesn't have a property that is admin. Well, because I have access to the prototype, user three, I can do proto is admin equals true. Okay, so now if I look, is admin is now true. Okay, so what happens if I create another user? Let user four, clear my screen, make it a little bit easier to see, equals new user. False, false, and false. So they can't do anything. User four is admin is true because the user prototype is admin is true. So any object now that inherits from the user prototype will have is admin set to true. Right? And the way this works too is you can actually keep going up the chain all the way up to the object prototype. I'm just doing this for the sake of illustration, but hopefully that made sense. So if you're able to pollute a parameter on the object prototype, any objects that inherit from that prototype will now have that additional property. Okay, so hopefully that makes sense. So just some general recommendations, and like I said, there's a lot more documentation on this than I can present here. But just first, whenever passing objects to other functions, ensure that all keys are defined or use null prototype objects. So one thing that I forgot to show is that this won't work if an object already has that property defined on it. So if I come back over here and I try this again and I say user3 is tall equals true. Okay. And then I try to set I try to pollute the is tall object or is tall property on the user object. My cat's getting ready to walk on my keyboard, trying to shoo him away. Proto is tall equals false. Okay, so now if I go back and I look at user one, is tall is false. User two is tall, it's false. But if I look at user three is tall is true, because user three already had that property set on it. So it has its own property. User three has own property is tall. Helps if I. So that's true. So if I look at user two now, has own property is tall. That's false. So what was happening here when, well, I'm getting ahead of myself. Let me, let me go back to this. I'll say what I was going to say when we get into the lab. So you want to make sure that any objects that you pass to other functions have any properties that all keys are defined, right? And that will prevent the prototype pollution vulnerability, because it will not have to look up the prototype chain to find that property. Validate user input and reject any unrecognized properties, and use defaults for any missing properties. And like I said, there's a ton more. I can't cover it all in this video, but like I said, I'll link to the documentation and the Portswigger labs in the description box. And I strongly encourage you, if you're looking to get into penetration testing, application security, bug bounty hunting, whatever, I strongly encourage you to take a look at those, and definitely something to get familiar with. So, okay, let me now go back over here. So I have already registered an account. I've gotten logged into Galaxy Dash. And this is just a delivery service, an intergalactic, I guess intergalactic, yeah, I guess delivery service. So you can schedule deliveries. The interesting part of this app here is this team management. Okay, if I add a new user, tester2 at test.com, give them a password, tester2, and just give them a viewer role. Well, so now if I modify the permissions for tester2 and I come over to my Kaido, I can see that the user object is being modified. Okay, I'm sending a put request to this API/team/7 endpoint with the permissions, with the updated permissions in the request body. So I'm going to send this over to my replay, and whenever you're, well, let me get ahead of myself here. So I also want to show you this. This is something that you can find if you do any kind of fuzzing on this API endpoint. Usually with these labs, there will be an API admin endpoint. So if I send that, I get this error: admin access required, and the message here is admin check failed. So this is telling me that the application is looking for an is admin property on my user object, and presumably it wants that value to be true. So this is a bit of a hint for us that this is the parameter that we need to pollute. Okay. So now if I come back over to my other request here, so what I want to do first is show just confirming confirming a prototype pollution vulnerability. So if I do this __proto__, and then I do status, and I'll set it to 510. Okay. Send that, and I get user permissions updated successfully. Now, what happens? I probably should have showed you an invalid request before I did this, but it's all right. So now if I send it an invalid JSON, I can see that I've actually updated the status for an invalid request. So I'm just going to reset that to 0, and then send this. So this is the default, right? So this 400 bad request error is the default. This is my polluted version, and you can see I'm able to influence what the status code that gets returned is. So I've now confirmed a prototype pollution. So what I want to do now is go back to that parameter that we saw on the admin endpoint and just say is admin true. Okay, and user permissions updated successfully. And now if I come back over here and I repeat this request, we can see that it succeeds because my user object now has the property is admin set to true, because I was able to pollute the object prototype that it was inheriting from. And because I was able to do that, then all uh, all user objects that inherit from that don't already have a is admin value set on them, they don't have their own property is admin set, will now have is admin true, and everybody will have admin rights. So that was that lab. Like I said, I really had a good time with this one. It wasn't something that I was. It was something I had seen, something I was kind of familiar with, but not something I had spent a lot of time digging into. So I really enjoyed being able to dig into this, and just having the opportunity um, to go through that. So I hope you enjoyed the lab. I really appreciate it, and we'll see you next time.